positive and negative feedback loops are important to controlling hormone levels in the human body. In this video, we'll use visuals from Visible Body Suite to go over the key characteristics of each type of feedback loop and how they differ from one another. Let's start with negative feedback loops, since they're more common. Overall, the role of negative feedback loops is to maintain homeostasis. When a change from a set normal value is detected, such as a high or low level of a particular substance in the bloodstream, endocrine glands and the brain act to return that value to its normal range. For example, when beta cells in the pancreas detect elevated glucose levels in the blood, they secrete insulin, which signals fat cells and cells in the skeletal muscle and liver to take up glucose. When alpha cells detect a drop in blood glucose, the pancreas stops releasing insulin. If blood sugar drops too low, the pancreas secretes glucagon, which signals the liver to release stored glucose. That's a simple negative feedback loop. It just involves the endocrine gland. The regulation of thyroid hormone, which controls your metabolism, is a good example of a complex negative feedback loop involving not only the thyroid, but the hypothalamus and the pituitary gland too. If thyroid hormone levels in the blood are low, the hypothalamus secretes thyrotropin-releasing hormone, which signals the pituitary gland to release thyroid-stimulating hormone. When the hypothalamus in the brain detects sufficient levels of thyroid hormone in the bloodstream, it stops secreting thyrotropin-releasing hormone. Now let's look at positive feedback loops. Instead of maintaining homeostasis, positive feedback loops intensify a physiological change or process occurring in the body. One of the biggest changes a body can undergo is childbirth, a great example of a positive feedback loop. Uterine contractions during childbirth activate stretch receptors in the smooth muscle of the uterine wall that alert the hypothalamus, which signals the pituitary gland to secrete oxytocin. This causes more contractions, and therefore more stretch receptor activation and more oxytocin release. After delivery, the feedback loop ends because the stretch receptor signals stop. Now let's review. Negative feedback loops can be simple or complex, and they maintain homeostasis. They are also more common than positive feedback loops. Positive feedback loops intensify changes in the body, enabling certain physiological responses and processes, like childbirth. To learn more about hormones, how they're regulated, and the roles they play in the body, check out Visible Body Suite at visiblebody.com/VBSuite.